Today, we're going to learn how to take the derivative of exponential functions. So these are things like e to the x, 5 to the x, 8 to the x. We noticed that what we've done before is that the exponent has been a number. Now the base is going to be an exponent. So we know, or is going to be a number. So we know how to deal with x to the 8th. Its derivative is 8x to the 7th. But if we have 8 to the x, we don't know how to deal with that yet. So that's what we're going to learn today. So to get started, we'll think about the number e. So remember, e is just a number like pi. E is the number 2.71828. It keeps going on forever. It's irrational, so it cannot be written as a fraction, just like pi. But e to the x, that function looks like this. All exponential functions have graphs that look similar-ish to this. And if we find the derivative of this, if we tried to sketch the graph of the derivative, we notice we have small slopes, positive slopes, small positive slopes, bigger positive slopes. And what it turns out is that the graph of the derivative of e to the x looks just like e to the x. So the derivative of e to the x, this is our favorite derivative ever. It's the easiest one. The derivative of e to the x is just e to the x. This is e to the x should really be your favorite function at this point because taking its derivative does nothing to it. It doesn't change it at all. In general, if we have a number a, the derivative of a to the x is a to the x ln of a. So e behaves nicer than other numbers, but still works. So what this would be telling us is that the derivative of 8 to the x would be 8 to the x ln of 8. Remembering that ln of 8 is just a number, ln of a is a number. Okay, so we can do a few examples here. So 5e to the x, we leave the 5, and we take the derivative of e to the x, which is just e to the x. So the derivative of 5e to the x, still 5e to the x. 5 to the x, that's like an a to the x, so its derivative is 5 to the x ln of 5. X cubed is like what we did before. We'll just do a power rule on that. So we get 3x squared. Now 3 to the x, that's exponential because the x is in the exponent. So that's 3x ln of 3. Okay, we can keep chugging along. So I want the slope of the tangent line at the point when x is equal to 0. Slope of the tangent line is just the derivative at 0. So this problem is just asking for f of 0. We have to start out by finding f of x. That'll be 3e to the x plus 4x minus 1. This is all just a polynomial, so it behaves like what we were doing before. Now I need to plug 0 into that. So I get 3e to the 0 plus 4 times 0 is 0 minus 1. E to the 0 or any number to the 0 is just 1. So this is going to be 3 minus 1, which is 2. That's the slope of the tangent line. We could write the equation of the tangent line if we wanted, but the problem doesn't ask us to do that. It just asks for the slope. This next one's asking for the derivative. 5x just becomes 5. Square root of x is x to the 1/2. So it's 1/2 x to the negative 1/2. Those first two were just a power rule, what we were doing before. E to the x stays e to the x. 1 becomes 0. And then 3 to the x, well, that's what we've been doing today. That's minus 3x ln of 3. So remember, you just have to be careful where the x is. Is it in the bottom or is it in the top? And that dictates how we deal with things. And so this last problem, 4 to the x will become 4x ln of 4. 5x becomes 5 to the x ln of 5. And then x to the 4th, that's where we do the power rule, 4x cubed. And then same, we get 5x to the 4th. So just be careful where the x is and where the number is, and you'll be good.